The state of stress is given like this. 30 compression 120 120 on positive x phase it is clockwise 40, therefore all phases this is 40. It should not be an assumption. One side it is different, other side is different. Shear stress means there is complementary. Okay, this is the state of stress. Next, we need to plot using Mohr circle. First, on the this is sigma negative. Let me take that. Sorry, sigma positive. This is sigma sigma positive positive. This is sigma negative. This is tau clockwise. This is tau counterclockwise. Okay, we have done this. So sigma is minus 30 and the x phase on y phase we have to look at. X phase it is minus 30. Minus 30 is here sigma positive, sigma negative, minus 30. And the x phase it is rotating the phase in clockwise direction, minus 30 and 40. Minus 30 and 40. This is the point. Minus 30 and 40. Minus 30 and clockwise 40. You can draw a line like this and indicate this point as x, this point as capital X. Okay, minus 30 and clockwise 40. And the y phase, it's plus 120. This is minus 30 and 40. And the y phase, it's plus 120 and then counterclockwise 40. Plus 120 is here and counterclockwise 40 is here. Counterclockwise 40 is here. Indicate this as your y. Right? Next, join these two lines with a straight line. Join these 2 points with a straight line. Okay. Next, mark this point where this line connects intersects the horizontal line as point C. Now taking are you able to understand up to here? Did you understand this? Did you understood this up to here? Hello, one of you unmute and tell me. Did you understood up to here?
Yes, sir.
Right. Next. Yes. Tell me. What is your doubt? Yes. Now this point as a center. Draw a circle. Either this as radius or this as radius. Draw a circle. Okay. Now, wherever this circle meets this point, whichever is maximum, since this on this line, on the horizontal line, there is no shear stress. If you consider this horizontal line, there is no shear stress. But any point on this circle, this is called as Mohr circle. Any point on this circle, there is a combination of shear stress and normal stress. But on this horizontal line, there is only normal stress, and we will call it as principal stress. I will indicate this point as P1 sigma. Instead of sigma P1, I am calling it as P1, principal stress P1. Okay. I will call this point, I will call this point as principal stress P2. Principal stress P2. This principal stress P2. 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 This is P1 and P2. Now from from the origin, this point, from this point to this point, from the origin to this point is my sigma 1. Draw a line if you want. You can calculate, you can just count. See, this is around 130 MPa. I can write sigma P1, which is equal to 130 MPa. Isn't it 130, 132 MPa around this point? If you can draw a line, draw a straight line if you want to measure. Since you can measure in the graph sheet, you can directly measure. But since here I don't have the option. Okay, I'll try to smart dimension it if possible. It is not possible. Okay, give me a moment. Try to draw a line. Try to draw a horizontal line. From this point, from the origin to this point is your sigma 1. It will draw it. I'll try to measure it in case if it's possible. I'll distance between smart dimension, vertical dimension, horizontal dimension in this point. Okay, since I've already dimensioned it, it is not taking. But you can see from the graph sheet, it is. I will write it here. From the graph sheet, it is sigma P1. Sigma P1 is around sigma P1 is around 132 MPa. 132 MPa. Sigma P2 is this point, is from the origin to this point is 40 MPa, around 40 MPa, right? 40 MPa, I will write it as 40 MPa. Sigma P2 is equal to 40 MPa. Next, I need to the point X, my state of stress, minus 30 MPa and then 40 MPa, 120 MPa and 40 MPa. My state of stress is this point X and Y. This is on X phase, the state of stress is this, and the state of stress is given by the point X and Y. This is the state of stress. So in order to get the principal stress P1, how much angle this plane has to be rotated? My state of stress is given by that 130, 30 MPa, 40 MPa, something like that in the problem. But in order to get my principal stress, by what angle I should rotate my x phase so that I get principal stress P1. So what I will do, I will measure smart dimension. I'll measure from this point or from this line to, I'll draw a line. This is more for my reference. You can draw in the graph sheet directly. I'll measure smart dimension from this line to this line. This is my theta P1, theta 2 theta P. This is my 2 theta P. Okay. This is around, sorry, I made a mistake. Give me a moment. This X phase, when I'm measuring the theta P1 or theta P2, I should go always towards theta P1. I should not cross theta P2. Therefore, for my theta P1, this is my angle. First, let me measure theta P1 from my X phase to theta P1. This is how I should measure. I should not bypass P2 and go to P1. X phase to I have to go to directly P1. This is my theta P1. Okay, this is 151.9 degree, 151.93 degree or 152 degree. Okay, let me write it. So what I have done from my x phase, what angle should I rotate my the state of stress to get principal stress P1. So for principal stress P1, I have to go in the clockwise direction. This is clockwise direction. Okay, you should not go in the anti-clockwise direction. You should not bypass go to P2 and then go to P1. This is how you have to measure directly to P1. Okay, now let me go there. See, before that, you can see x and y are 180 degree apart. X and y are 180 degree apart. It means to say that in case of my Mohr circle, whereas here in case of my Mohr circle, the angle is 2 theta. If there is an angle theta is equal to 10 degree, in case of Mohr circle it is 20 degree, because the x phase and y phase are 90 degree apart here, whereas when I wrote the Mohr circle, they are 180 degree apart. It means to say that my Mohr circle, it is 2 theta, whatever you're getting, we're representing it in terms of 2 theta. So what we got 2 theta is 2 theta p, which is equal to 151.93 degree. It is 2 theta p. Theta p, this is clockwise. Since I measure in the clockwise direction, it is theta p. Theta p, which is equal to minus 70, how much? Minus 1, minus 76 degree, minus 176 degree. Theta, since this is theta p1, since I went to in the previous theoretical problem we did it all the circles, that is whether it is sigma x minus sigma y is positive or not. Don't worry about this whatever directly get, since I'm rotating towards the principal stress p1, this is theta p1. Theta p2, which is equal to theta p1 plus 90 degree, or theta p2, which is equal to minus 76 plus 90 degree, which is equal to 14 degree. 14 degree. Okay. Next problem we'll understand. Try to cope up with this problem. Next, in order to measure the maximum shear stress, what I will do, I will just draw a line from the center, from this point to this point, and then once again I'll draw a center line from center point to the circle. From the center point, I'll draw a straight line like this. Now, in order to measure tau max or tau minimum, this is tau max. Whatever this line is there, right? This is my tau max or tau minimum. This is around 8.50 in this case is 85 MPa. Tau max is 85 MPa. Let me write this. This will be also same. This will be also same. This I will call it as T max or tau max. This will be, since this is a radius, this will be also same T max. Now in order to measure this phase, always my bottom phase is my S1 phase. That is, that anti-clockwise is positive. So in order to measure that, always I go with reference to my x point only. So in order to go to the maximum shear stress plane, how much that is from x to S1, how much I should rotate, that I will measure. I'll measure from this point to this point, how much I should rotate. This is 180 degree, 118 degree, 118 degree, 0.70 degree. This is my 2 theta S1. Let me write it. Tau max, which is equal to 85 MPa, 2 theta S 2 theta S1, which is equal to how much we got? 2 theta S1, 1 not 118 degree. 2 theta S1 is equal to 118 degree, or theta S1, which is equal to 59 degree, theta S2 is equal to 59 plus 90, which is equal to theta s2 is equal to 190, 100, 150, 150, 149, 90, 100,
149.
1, no, no, 90, 100, 100, 149, 149, right?
Yes, sir.
149 degree. Okay. 149 degree. This is theta s2. Now he has given the plane which is inclined at an angle 60 degree. There is a plane which is inclined from this. There is a plane theta. And you should take theta precisely. Theta is equal to 60 degree. You should see which what is theta. In this case, theta, this is clockwise from the vertical. Theta is equal to minus 60 degree. Whatever clockwise, you say this is clockwise. Since this is negative, this is clockwise. Now what I will do, I will I will from always my point is from x point. From my x point, theta is given as 60 degree. In my Mohr circle, it is 120 degree. When I am drawing in with reference to, when I am converting into x and y phase, that is in the x and y coordinates, when I am representing it as sketch, not in Mohr circle. When I am representing it as sketch, I will divide by 2. When I am converting into Mohr circle, that is the angle. If I am taking it is in representing it as in Mohr circle, I have to take it as twice the angle. Since theta is given 60 degree, from x point it is clockwise 60 degree. Clockwise 60 degree. From x point, I should draw a line. I should like this. Let me represent it. Assume that. Assume that this is given like this. Whatever you got, I'm just giving a general case like this. This is my x point and this is my y point. This is my tau max, tau minimum. Okay. Now whatever, however you got. See, for normal theta, to get that 120 degree, I have to rotate in clockwise direction by 120 degree. From me, I have to rotate this line by 120 degree. That is, keep the protector here at the center point. Okay, center point, rotate it by 120 degree at the center point. Rotate, keep the protector at the center point, rotate it by 120 degree. Like this. Okay, you what you have to do, you have to keep your protector on this line. On this line, I have not written properly this, since there is a confusion. Let me show you, come to know. Okay, if I draw graphically, you'll come to know. This is always a confusion, but what you should know, you should rotate it by 120 degree in clockwise direction. How I will do, you will see that. I will draw a line. I will draw a line. I will draw some line. Draw with reference to this. From this point, this are the center. This point has to be rotated 120 degree. I will just draw a line like this. A line like this. And then I will measure 120 degree. But you can, in this protector, you can draw it yourself. These are the center. You can, what happened? Give me a moment. I will come wrongly. From this point, from this point, it has to pass to the origin like this. Just to pass the origin. I will draw a line. Okay, and this angle has to be 120 degree. From here to this point, it has to be 120 degree. Since this clockwise, the clockwise 120 degree, this I have measured in clockwise 120 degree. 120. Therefore, this comes. Give me a moment. Sorry, I made a mistake. I have taken with this as a reference. From this point to this point, it is 120 degree. 120. This is 120 degree. And whatever the point which you get, whatever if you rotate the 120 degree, this is your n phase. This is your N phase. I'll call it as N phase, and this is your T phase. This is your T phase. T. N phase and T phase. Now, in order to measure the, so what I have done, I've calculated the theta S1, theta S2, tau max, tau minimum is plus or minus that, theta P1, theta P2, sigma P1, sigma P2. There is a plane in which I should get sigma normal, which is nothing but sigma normal, which is equal to sigma x dash into tau dash, and then sigma t or tau and t, which is equal to sigma y dash and tau dash, which is equal to sigma y dash into tau, sigma y dash and tau dash. Let me write it. For that this is your n, this is your tangential. At this point, at the n phase you'll get sigma x and tau dash. In the at the t phase you'll get the sigma y dash and tau dash. Tau dash remains the same, x dash and y dash will change. So how to measure it? Draw a center line from this point.
அன்னைக்கு போட்ட சாப்பிடலையா உட்காந்துட்டு
Unmute your mic. From this point, to this point, draw a vertical line. Let's say vertical. Okay, give me a moment. Try vertical line. Or I have option here only. You have option. I have option here, vertical line. I will draw a vertical line, vertical center line from this point. Give me a moment. Line. Draw vertical line from this point. Yes, this point to this point. This point where this is meeting, this is your, say, some 119 MPa or 118 MPa is your sigma x dash, okay. And then from here to this point, from here to this point from the origin, it's at a distance of around 28 MPa, okay. Tau remains the same for both the cases. Measure this from 45.8 MPa. So this is sigma n, is the x dash is, since this is sigma n, it indicates x dash and tau dash, it is nothing but 118 point something MPa. Sigma n, which is equal to 118 MPa, and tau dash, what was tau dash? Tau dash is 45.8 MPa. 45.8 MPa. Okay. And then sigma y, it's 28. Okay. 45.8, 28, 45.8 MPa. This is a sigma, this is a tau dash. Let me explain this. What I have done, X sigma x phase is minus 30 MPa. I should talk about x phase and y phase only. X phase is minus 30 MPa and clockwise 40. Y phase plus 120 and counterclockwise 40. So I have done x phase minus 30, x phase minus 30 is this point minus 30, and then clockwise 40 is this point. Y phase it is plus 120 is this point, and then counterclockwise 40, this is counterclockwise axis, this is counterclockwise 40 x phase we have plotted. From this I will draw a straight line, and then I will get point C. From this point C as the center, either XO as the XC as the radius or CY as the radius, draw a circle. This circle is called as Mohr circle. This Mohr circle, wherever it intersects the horizontal line, on this line there is no principal and there is no shear stress. This point is P1 and this point is P2. Whichever the maximum is called as P1 and the minimum is called P2. If there is minus 300 and minus 200, minus 200 is P1, minus 300 is P2. Sigma P1 and sigma P2. Okay, now in order to calculate the planes, there is a principal planes, I need to rotate my x phase. You should not bypass, you should not pass P2 P2 and come to P1 directly from x phase to P1. How much it is? In case if this is x, I need to rotate directly like this. In case this is x, I cannot go like this. I have to rotate like this anti-clockwise. When I do one more problem, come to know. So x phase, this is 151.93 degree. In case of Mohr circle, it is 2 theta. In case of x and y, what we represent in terms of sketch, it is theta. So it is half of that, around 75 point something. It is theta p1. Since this is measured in the clockwise sense, to arrive at theta p1, so that is sigma p1. This will be minus 75 point something, and theta 2 will be plus of that minus 175 75 point something plus 90 15 degree, whatever will be theta p2. Now, in order to measure the tau max, from the center point, draw a vertical line. Draw a vertical line meeting the Mohr circle. Either this is the radius, this is whichever take the radius. This is tau max or tau minimum. Now, in order to measure the shear stress planes, I have to rotate my x plane. Always the x plane with to S1 plane. This is standard from x plane to S1 phase. This is S1 phase. Always at the bottom is S1 phase. So I rotated it by 118.07 degree. So in this 2 theta S1. In case of XY, there is a sketch. That is in case in general it is half of that. That is 58 point something. This is theta S1. Okay, since this is measured in counterclockwise direction, theta S1 I have measured in counterclockwise direction. This has to be positive theta S1. Positive theta S1. Hence I have taken theta S1 as positive. Hence I have taken theta S1 as positive 59 degree. Okay. Next, in order to measure, there is a plane which is making 60 degree. In Mohr circle, it will be 120 degree. Always with reference to x-axis. Since it is minus 120 degree, I have to rotate it in clockwise direction. I have rotated it by 120 degree in clockwise direction. Draw a line from this center. Take the protractor, keep the protractor at this point at the origin C. At the origin C, measure 120 degree from with respect to point X. Then what you have to do, this point where it meets the Mohr circle is n axis and the other point is t axis. That is the t point, n and t axis. That is normal and tangential axis. That is sigma normal consists of sigma x and tau dash. Sigma tangential consists of sigma y dash and tau dash. Okay. Sigma x dash is given by this point. Okay. But we didn't calculate sigma normal, and we calculated sigma normal and sigma tangential. In that we are not calculated sigma x dash and tau dash. Okay. Sigma x dash is given by this horizontal measurement. Since this is sigma axis, whatever you measure here from with respect, always you should measure with reference to the origin, not from the center. From center origin, whatever you measure, this is your point, say around 118 point some degree is your sigma x dash. This is your tau dash 45.8 degree. Similarly, whatever you measure from the origin to this point is your sigma y dash. This is on 28 degree, and this height remains the same, tau dash 45.8 degree. Is this clear? Is this clear? Is this
Yes, sir.
right? Mekala, can you solve by
Yes,
yourself?
sir.
Clear? Abdul
Yes,
Razak,
sir.
Ashit, Daniel in the first class, I think Pratish, Paul. If I solve one more problem in the next class, will come to know. Rakshit, Sanjay, ಸಂಜಯ್
Yes, sir.
ಅರ್ಥ ಆಯ್ತಾ? Sushil Kumawat, Umesh, did you understood this?
Yes, sir.
Okay, I will stop at this point. Next problem, once if I solve, you will come to know. So this is what always with reference to x-axis, I should rotate it to p1 axis. P1 this means for p1. Always with reference to x point, whether x point can be here or here anywhere. X with reference to x point, I should rotate to s1 point, which is at the bottom. Always with reference to x point, I should rotate to get in plane, and then t plane will be opposite to that, n and t planes. Okay, I will stop at this point. Thank you.